Back again for this second part of our lecture here. We're going to work an example and see what we can do with this. So the example says we've got a radar gun. We got information about the speed at two different locations. We got information about the distance between these two locations. We're told that it is constant acceleration. We can see that from our two velocities, final one of 88, initial one of 66, that we're speeding up. We want to know how long. We want to know the time it took this car to travel the 400 feet between these two locations. So if we're in lecture, we would stop right now, and I would encourage you to perhaps pause, write out the values you know, and determine which equation you would use to solve this problem in just a single step. Should be pretty straightforward, but you should try that now. And I'll continue on because you can pause or just listen. Writing it out, what I would encourage you to do, get my right tool here, is use our same nomenclature. So in this case we know our S2 minus S1, or our delta S, is equal to 400 feet. Okay, so we're not given S1 or S2, but we're given the difference, and that we can work with that. We also are given a velocity at the start is 66 feet per second, and the velocity at the end is 88 feet per second. Okay, and we want to find delta t. Alright, so if I look at these three equations, the first one, I know S2 minus S1, I know V1, I know V2, and there's what I want to find. Always look probably first for what you want to find. So right away we could eliminate this equation because it doesn't have delta t in it. Still a valid equation, but we'd have to take a couple steps. We might consider this equation, but we don't know the acceleration. Okay, we could calculate the acceleration, change in velocity over change in time. We don't know the time, so we'd actually have to come down here and get the acceleration from that equation, then plug it in up here, and then solve a quadratic for a lot of work. Okay, so step one, or equation A here, is our quickest way. So we will substitute in for that. We got S2 minus S1, so we'd have 400 feet, and that's going to be equal to our average velocity, 66 plus 88. A little awkward to write on the screen like this, feet per second, over 2 times delta t. Okay, I'm going to try something out here, and my OneNote program, I can hopefully type in delta t as something like this: 400 times 2 divided by 66 plus 88, just like you would on your calculator. So 5.1948, or about 5.2 seconds to go that 400 feet, accelerating from 45 to 60 miles an hour. Okay, you can pause that, rework it, think about it. I'll go on.